Hi everyone, it's Julius. So Prometheus is great for monitoring your systems and services because it's so flexible and powerful, but that also means that there's a lot that can go wrong when you're getting started with it, especially when you don't know exactly yet what you're doing. So in this video, let's talk about some of the biggest pitfalls you can encounter and how to avoid them. So this first one is a classic, cardinality bombs. This happens to almost everyone once or twice when you get started with Prometheus and you discover how useful labels are to split up a metric by all kinds of dimensions. And don't get me wrong, labels are awesome, but you have to use them responsibly or you can easily blow up your Prometheus server by creating way too many time series. For example, maybe you're counting requests in an HTTP server and you're splitting up your request counter by the request method. That's usually totally fine, since the method label will only ever take a couple of well-known values. But maybe one day you get the idea that it would also be super useful to know which user sent the request, and you add a user ID label to also split up the metrics by. Now, at least if you have more than just a handful of users, that can easily lead to an explosion in the number of time series. Keep in mind that each unique set of labels automatically creates a new time series in Prometheus that the server needs to index, store, and process, and the number of series is usually the primary scaling bottleneck in a Prometheus server. So be careful which labels you split up your metrics by, and try to use mainly labels that have a small and well-bounded set of values. So definitely you'll want to avoid putting public user IDs, email addresses, or full HTTP paths into your labels, because those usually can take a huge number of different values. And at the same time, there's no absolute hard rule to this, but overall, in a large Prometheus server, you'll typically have a total budget of a few million time series at once. And you'll have to choose your metrics and the labels they're split up on and the number of targets accordingly, just so you stay somehow under that total number that your server can handle. Before we get to the second mistake, I'm just still starting out with this YouTube channel, and so far it's so new and so unknown that YouTube won't show it to a lot of people yet. So if you like the content so far and you want to support the channel, please give the video a quick thumbs up, and maybe you will even want to subscribe in case you want to see more videos like this one. Okay, on to the second one, aggregating away too many labels. So often when you're writing alerts, you don't want to alert on each individual time series in your expression, but on some aggregation of them. For example, you may not want to alert on each individual error rate coming out of your service, but on the total rate. And you can get that total using the sum aggregator, but by default, these aggregators throw away all labels of the underlying time series, even if the labels are common across all the input time series and could be really useful later on. So for example, in the alert manager, all the routing, aggregation, silencing, inhibition, and so on happens based on the labels of your alert, and the final notification will also often contain all alert labels. So the more labels you preserve early on in the pipeline, the more useful your alerts will be. Especially the job label or some equivalent service grouping label you'll usually want to preserve in your aggregation so you can route and silence based on them later on. So one thing you can do is to add a by modifier to your aggregators to keep specific labels, or even better, use a without modifier instead to only throw away exactly those labels that you actually want to aggregate over. And that automatically keeps the rest of your labels. On to pitfall number 3. When you're writing PromQL queries, it's easy to select unintentional time series if you don't scope your selectors correctly. The problem here is that multiple unrelated services can expose the same metric name and potentially even with a totally different semantic meaning. And even if that's not the case today, when you're writing your query, a new service with a conflicting metric name could appear at any time and break your dashboards, or even worse, your alerting rules. For example, if you're selecting the error rate for a job by just a naked metric selector like this, it could be that another job exposes the same error metric tomorrow, and now you'll be alerting on that job's error rates as well. Sometimes that's of course what you want, but you don't want to run into this unintentionally. So you'll always want to scope your selector specifically to the job or service or other kind of grouping that you want to write the query for to make sure that you only select the metrics you intended. As the fourth point, let's talk about the for duration field in alerting rules. So the for field allows you to configure for how long an output time series needs to be present across multiple successive rule evaluation cycles before the alert turns from a pending to a firing alert. And the idea here is to give the alert a time tolerance before it actually goes off. So what happens if you don't set this field, and can you maybe even omit it for most alerts? Let's have a look at a first simple example, alerting on instances that are down using the up metric. By the way, if you want to learn more about the up metric and where it comes from and what it does, check out this other video I made up here. Alright, now this alerting rule is a bit too trigger happy. If even only a single scrape fails, it will immediately alert you without any time tolerance. But occasional failed scrapes should usually not be an issue at all. So you probably want to add a for duration of a couple of minutes to this kind of rule to make it robust against such short blips. But maybe now you're wondering, what about alerts that already have some kind of time averaging baked in? For example, this error rate alert already averages the computed rate over the last 5 minutes of data. But you also have to consider what happens when the Prometheus server starts up completely fresh or when it hasn't been running or collecting data for a while. Then we might not even have 5 minutes worth of data yet when this rule runs, and the rate might actually just be computed over the last 30 seconds of data or so that we really have. And if there's a spike at that point in time, we will create a firing alert immediately, not only after 5 minutes. So again, introducing a for duration fixes that problem. And in general, you will want to add a for duration of at least a couple of minutes to most of your alerting rules to make them more robust. Just keep in mind that this also leads to slower reaction times for your alerts, so you'll still want to find some kind of balance for this time tolerance. As a fifth pitfall, let's talk about gappy or unreliable rates. So these can happen when you're using any of the functions in PromQL that tell you either how fast the time series is going up or down. Those are the rate, irate, and increase functions for counters, or deriv and predict linear for gauges. And by the way, if you're curious about the difference between counters and gauges and all these different metric types, check out this video I made up here about the 4 different metric types in Prometheus. Now, the important thing for all of these functions is that they need to see at least 2 samples for each time series under the provided time window to be able to tell how fast the time series is going up or down, right? If they only get 1 sample, they can't tell anything from that, and they will just omit that time series completely from the output at the corresponding time step in the graph. For example, if you scrape a metric every 15 seconds and then you try to calculate a rate from that over a 20-second window, there's a good chance that those 20 seconds will often not cover 2 samples, so you get a gappy rate. And if you take that to the extreme and decrease the rate window to only 16 seconds, you only get an output point very occasionally. And then finally, if you make the window even smaller, like 14 seconds, you'll never ever select 2 data points. So at that point, the graph will just be completely empty. So as a lesson from this, you absolutely want to make sure that your rate windows are always large enough to be robust to bad window alignments, but also to the occasional failed scrape. And a good practice is to set them to at least 4 times your scrape interval to make sure you always get an output. Let's get to the 6th and last mistake to avoid, using rate and related functions with the wrong metric type. So while PromQL is statically typed on a different kind of level, it cannot directly tell you if you're passing the wrong type of metric into a function that isn't designed to deal with it. For example, the rate, irate, and increase functions are designed to only work for counter metrics. That's because they treat any decrease in the sample value under the provided time window as a counter reset, and they will try to neutralize away the effect of that reset as much as possible. As a result, they'll only ever return positive values and never anything negative. So if you accidentally pass in a gauge metric that can naturally go up or down, like memory usage, you'll just get back an incorrect value whenever it does go down, because the rate function will incorrectly think that this decrease was a counter reset, and it'll compensate for that. So you just have to be careful to only use those functions with counters. And by the way, the same danger exists the other way around as well. The deriv and predict linear functions are specifically designed to tell you how fast a gauge is going up or down. And since those functions don't have any concept of a counter reset, you will get incorrect outputs when you try to use them with counter metrics. So again, you just need to be careful to only pass in gauges into those functions. Now, in the PromLabs query builder for PromQL, I do apply some heuristics based on the metric name to try and guess whether you're passing in the wrong metric type, and then show you a warning and a button to fix the situation. Now, that won't be perfect, but hopefully it can help at least a little bit. Alright, so hopefully these tips will help you avoid some of the most common mistakes that you can run into with Prometheus. And if you want to learn Prometheus properly and from the ground up, check out my trainings at training.promlabs.com. Also, go like the video if you found it helpful and subscribe if you want to see more. And I hope to see you in the next one.